The design of the McDonnell Douglas F-4 Phantom II has surpassed 60 years. Initially intended for carrier-based operations, it swiftly evolved into one of the most significant land-based tactical aircraft in the Western world. Over 5,200 Phantoms were manufactured, and today they continue to serve in Greece, South Korea, Turkey and Iran. Originating in the early 1950s as the McDonnell AH-1 supersonic attack aircraft, it transitioned in May 1955 into the F-4H-1 two-seat fleet defense fighter. With its Mach 2 plus performance, the F-4 boasted an armament featuring 4 Sparrow air-to-air missiles, semi-recessed in the lower fuselage and complemented by a robust search and fire control radar. Thus, the F-4H emerged as the world's first fighter equipped with self-contained search and destroy capability. On May 27, 1958, the XF-4H-1 prototype made its debut at Lambert Field in St. Louis, with test pilot Bob Little at the controls for its inaugural flight.
Our intention on that flight was to take the airplane supersonic on its first flight. We had done that 4 years before in the F-101, and it was certainly something to be accomplished in the F-4. It didn't work out that way. Landing gear didn't come all the way up. And on that flight, a hydraulic system failed on takeoff, so had to bring the airplane in after about 20 minutes of learning how to fly it well enough so I could land it.
Despite encountering challenges during its maiden voyage, as the XF-4H taxied alongside examples of McDonnell's other major fighter program of the period, the F-101 Voodoo, it became evident that the company had a triumph on its hands. The narrative of the Phantom also encompasses General Electric, which supplied the J79 turbojet engine. In 1951, the company embarked on developing a new axial flow engine that aimed for low weight and excellent fuel efficiency at Mach 0.9, while still possessing the strength and thrust for Mach 2 performance. To accomplish this, the J79 incorporated innovative design elements, notably the variable stator compressor with adjustable blades and an afterburning exhaust nozzle essential for lightweight and optimal performance at very high speeds. This nozzle utilized secondary air to regulate the expansion of the primary exhaust, also serving to cool the engine, thus obviating the need for costly metallurgical solutions. Mechanically interconnected, 2 sets of nozzle fingers dynamically adjust, opening and closing to shape the exhaust for optimal balance between thrust and fuel consumption across the engine's entire operating spectrum. This innovation results in a substantial 2/3 boost in thrust, albeit at the cost of exorbitant fuel consumption. The full-scale variable stator compressor unit underwent its inaugural test in August 1953, yielding performance figures so impressive that the test crew initially suspected instrumentation malfunction. At much the same time, the afterburner was connected to a J73 turbojet and tested with encouraging results. The integration of the afterburner with the J79 engine culminated in the complete new engine's placement in the test cell by June 1954. Approximately 150 hours of testing on the J79 was supplemented by an additional 800 hours on the J73 for further evaluation. A pivotal moment in the test program occurred with the inaugural field run of the J79 engine. Upon ignition, the test crew promptly scrutinized the instrumentation. Subsequently, with the engine throttled to idling speed, ground and flight test engineers meticulously inspected it for any signs of fuel or oil leaks and other potential failures. Once this initial examination was cleared, the engine underwent higher speed testing before being shut down. In May 1955, the groundbreaking new engine took flight, housed in a nacelle beneath the belly of a converted North American B-45 bomber. Historic footage captures the modified B-45's ascent on May 20th, 1955. After the B-45 achieved stable flight, the J-79's nacelle was extended, facilitating initial test runs to confirm its capabilities in steady, level flight. Subsequent tests included air starts, essential for any advanced engine. The J-79's performance was thoroughly assessed across various flight conditions, proving its mettle with afterburning thrust ratings of up to approximately 13,000 pounds. The inaugural flight-worthy J-79 was transported across the United States to Edwards Air Force Base in California, where it underwent unpacking, ground testing, and installation for flight trials. This process proceeded smoothly, with fuel, oil, and over 100 electrical connections established without major issues. The XF-4D-1, a prototype of the high-performance naval interceptor Skyray, was selected as the test aircraft for the flight trials. Ground runs were conducted at both dry and afterburning thrust levels to validate the fundamental installation. On December 8, 1955, under the command of test pilot Roy Pryor, the aircraft equipped with the J-79 engine embarked on its maiden flight. Taking off downwind to maximize runway utilization, the aircraft required approximately 6 miles of the renowned dry lake bed at Edwards, formerly known as Murrock, until 1950. The flight encompassed a climb to 18,000 feet before safely returning for an evening landing. The entire flight operation exemplified successful flight testing. The J-79 was soon cleared for operational service, and early examples of the type were installed right from the beginning of the Phantom's production run. By the late 1950s, the Phantom's prominence surged following the placement of its first production contract in December 1956. This overview of an F-4B naval model, temporarily loaned to the US Air Force, highlights the aircraft's key attributes. Positioned at the front is the pilot, with the radar officer seated behind. A ladder, visible inside the rear canopy, can be deployed to darken the cockpit, ensuring optimal conditions for viewing the radar screen. Despite being relatively spacious and conventional for the era, the cockpits are well equipped with displays and controls. Occupants are seated on Martin Baker Mach 5 ejector seats, engineered for safe ejections even at zero altitude and speeds as low as 150 miles per hour. Mach 2 performance is facilitated by the 2 fully variable ramp inlets for the J-79 engines. A splitter plate diverts the boundary layer of the slower moving air close to the fuselage, while the inlet ramp adjusts at speeds exceeding Mach 1.4 to regulate the shock wave pattern, ensuring an uninterrupted airflow into the engine. This system operates automatically, controlled by the aircraft's air data computer. Notably, Navy and Air Force Phantoms typically feature distinct tyre configurations. Both types of tyres boast the same diameter, but the Air Force variant, depicted on the left, showcases a broader design. This broader tyre offers an increased touchdown area, allowing it to be inflated to lower pressures, suitable for operations on the extended runways typically available to land-based aircraft. Positioned on the port side of the fuselage is a pneumatically extended ram air turbine, serving as an emergency power source to sustain essential systems in the event of engine failure. Operating down to a speed of 225 miles per hour, the turbine supplies electrical power, transitioning to hydraulic power for the landing systems thereafter. The centerline hardpoint for stores, Sidewinder tactical optical recognition carriage, is augmented by 4 substantial pylons situated under the wings. Along the leading edges of the wings are 3 section slats designed to maintain an even airflow over the wings and reduce stalling speed. This feature's efficacy hinges on boundary layer control, achieved by tapping air from the engine compressor and venting it through the depicted slots. This is one of the 2 trailing edge flaps, which are also fitted with boundary layer control. Similar to the leading edge system, these slots direct air tapped from the engines over the upper surface of the flap. This airflow manipulation enhances the effectiveness of these relatively small surfaces. The flaps have a maximum deflection of 60 degrees, with full flap setting employed during landing and half flap setting for takeoff. Lateral control is achieved through a combination of spoilers and ailerons, with spoilers utilized at high air speeds and ailerons at low air speeds. Each wing's underside features a hydraulically operated speed brake, enabling rapid deceleration from speeds as high as Mach 2.4 at any flight altitude without inducing buffet or altering pitch trim. Although extending the speed brakes during landings is safe, their effect is minimal at low speeds. The elongated low vertical tail addresses headroom constraints on US carriers' hangar decks and incorporates a powered rudder for yaw control. Beneath the powered rudder lies the vent for the fuselage's complex of 6 fuel tanks. The slab tailplane halves ensure complete pitch control under all flight conditions and are angled downward at 23 degrees to enhance directional stability by augmenting the effective side area of the rear fuselage. Positioned between the J79 tailpipes is the arrestor hook, typically housed beneath the rear fuselage fairing but deployed during carrier landings. This feature, retained on land-based Phantoms as well, has proven invaluable for achieving short landings on runways equipped with appropriate arrestor gear. Crafted from a special high-strength alloy, the hook is engineered to withstand the immense forces encountered during arrested landings. Heat resistance in the rear fuselage is enhanced through the utilization of stainless steel, titanium, and ram air cooling. Located at the far end of the tail is the compartment for the 16-foot braking parachute, essential for reducing landing distances on standard runways. The aperture in the tail facilitates the exit of cooling air, intentionally drawn into the rear fuselage structure above the engine exhausts. Renowned for its distinctive appearance, the Phantom has always stood out in the realm of aviation aesthetics. One of these distinctive features is the power folding of the outer portion of each wing, normally angled at 12 degrees. The folding system is engineered to reduce the Phantom's width for ease of movement on carrier decks and elevators. This feature, retained on land-based Phantoms as well, has demonstrated its practicality in various operational scenarios. With the wings folded, the internal plumbing for the boundary layer control system becomes visible. The sizable nose radome accommodates the 32-inch diameter antenna of the APQ-72 main radar. Positioned beneath the nose is the fairing for the infrared scanner, serving as a backup target acquisition capability should the main radar encounter jamming or failure. The Phantom entered operational service with the US Navy in 1961, prompting rapid conversion of squadrons from older aircraft types to equip the Navy's formidable carrier force. The section illustrates key elements of carrier-borne operations, featuring F-4Bs from Fighter Squadron 74 aboard the USS Forrestal, the Atlantic Fleet's inaugural Phantom unit, also known as the Bedevilers. Prior to each mission, a meticulous briefing sets the stage, followed by flight crews donning survival equipment on top of their flight suits. Upon the command from flight operations, crews proceed to their designated aircraft. Meanwhile, deck crews, distinguishable by different coloured vests for identification, finalise preparations for the mission launch. The pilot conducts a thorough walk-around check of the aircraft before both pilot and radar officer embark on the Phantom. The launch weight is indicated for the catapult officer's attention. In the fleet defence role, the pilot assumes control of the aircraft and oversees combat operations, while the radar intercept officer manages radar operations and initiates early interception procedures. Subsequently, both cockpit canopies are sealed shut, and the deck crew raises the catapult bridle in readiness for launch. The flight deck director meticulously guides each aircraft into position over its assigned catapult, carefully manoeuvring it onto the shuttle over the wheel section of the catapult. Subsequently, the bridle is securely attached, and any slack in the bridle is eliminated by nudging the catapult shuttle forward slightly. Simultaneously, the companion Phantom on the second catapult undergoes identical preparation, with cockpit checks also finalised. The deck director signals the pilot to advance the engines to take-off power. Finally, the director signals the launch, and the Phantom is hurled down the catapult run and over the bow of the carrier at a speed of 185 miles per hour. As the first pair embarks on their combat air patrol, another duo of Phantoms taxis towards the launch area. Upon reaching the designated spot, deflectors are raised to redirect exhaust gases away from the flight deck. Simultaneously, the shuttle is repositioned, allowing the next Phantom slated for that catapult to align its nosewheel unit over the shuttle and position itself in line with the catapult while the deck crew raises the bridle. This launch sequence continues with up to 4 aircraft dispatched almost simultaneously. Additional aircraft are brought up via the deck edge elevators. Enabling launches to proceed, including instances of triple dispatches. Equipped with a 2-person crew, potent radar, and an arsenal comprising Sparrow medium-range and Sidewinder short-range missiles, the Phantom was heralded as the world's first fighter with independent search and destroy capability, free from ground control, and proved invaluable for the US Navy in the 1960s. Its service capabilities were swiftly showcased through a series of world records. In December 1959, the Phantom achieved a zoom climb-to-altitude record of 98,556 feet. In September 1960, it secured 2 closed-circuit records at speeds of 1,217 and 1,390 miles per hour. Less than a year later, in August 1961, it established a low-altitude speed record of 903 miles per hour, followed shortly thereafter in November by an absolute world speed record of 1,606 miles per hour. Undoubtedly, one of the most remarkable early achievements took place in May 1961, commemorating the 50th anniversary of naval aviation. 5 prototype Phantoms embarked on a journey from west to east across the United States, completing the transcontinental flight in a mere 2 hours and 47 minutes, smashing previous records. Upon concluding their patrol, the Phantoms returned to the carrier for landing. Approaching at 150 miles per hour, each aircraft undergoes visual inspection to verify the lowering of landing gear and flaps. They're then guided down by the landing signal officer once the assistant confirms a clear deck. As the pilot aligns for approach, guidance is provided by an amber light known as the meatball, situated on the right side of the flight deck. The pilot keeps this lined up with the row of green lights to ensure that he is in the groove, the correct glide slope to fly the aircraft onto the deck and catch the wire. Different light angle approach settings are configured for each type of aircraft aboard. Following each landing, the wire disengages from the arrestor hook and returns to its position as the landed aircraft taxis clear, facilitating the prompt arrival of the next aircraft. Subsequently, the landed aircraft are lowered to the hangar deck via the 4 deck edge elevators to initiate the maintenance cycle before their next mission. Each of the 4 Forrestal-class ships boasts approximately 3.5 acres of maintenance area below the flight deck, though this capacity accommodates only half of the carrier's 90 aircraft at any given time. Throughout the 1960s and early 1970s, both the F-4B and the upgraded, more potent F-4J versions of the Phantom served as the backbone of the US Navy's air defense. Extending outward to a radius of 400 miles from the carrier, the Phantom maintained unrivaled effectiveness in combat air patrol until the introduction of the Grumman F-14 Tomcat. During the Vietnam War, US Navy Phantoms occasionally operated as attack aircraft from land bases while detached from their parent carriers. These F-4J aircraft, derived from the original F-4B, featured more powerful engines, drooping ailerons to complement the flaps, slotted and hence more efficient tailplanes, and an enhanced combination of AWG-10 fire control radar and AJB-7 bombing system for improved air-to-air and air-to-ground capabilities. The pilot assumes the primary responsibility of flying the aircraft, remaining fully engaged in ensuring all systems are functioning optimally and monitoring fuel levels while maintaining a vigilant visual scan of the sky for potential threats that may have eluded radar detection. In the rear seat, the radar intercept officer employs increasingly sophisticated equipment to monitor the tactical situation and provides ongoing updates to the pilot. The Phantom earned its stripes in Vietnam and remained one of the few US combat aircraft in that theatre never to be withdrawn. Throughout the conflict, it consistently demonstrated its ability to meet the diverse demands placed upon it and garnered deep admiration from its crews. However, the Phantom wasn't without its shortcomings, particularly in its early iterations. One notable flaw was its smoky power plant, which could inadvertently reveal the aircraft's position to adversaries. Another significant operator of the Phantom in Vietnam was the US Marine Corps, with a key marine aviation unit, Aircraft Group 13, stationed at Chile in 1968. Aircraft were stored in blast-proof revetments between missions to mitigate the impact of communist rocket and mortar attacks on airfields and to impede potential close assaults by Viet Cong sappers. Prior to boarding the Phantom, the crew conducts a thorough walk-around check to ensure the aircraft exhibits no visible defects. They inspect the underwing pods to confirm full attachment, complete loading, and proper electrical connection, as well as to ensure the safe handling of the 2.75-inch rockets. Examination of the main landing gear wheel well is conducted to detect any signs of hydraulic or fuel leaks. A brief inspection confirms that the Mach 4 20mm cannon pod is loaded with ammunition and free of apparent issues. The bomb load is finalized with triplets of retarded high-explosive bombs loaded onto the wing pylons by the ordnance crew, utilizing a specialized jack-up bomb trolley. Safety pins are inserted to secure the bombs before the trolley is removed. And safety wires are affixed to each bomb to prevent arming until after release. As it falls, the wire breaks, thus freeing the nose-mounted propeller to turn the requisite number of times and so arm the weapon. The two crew members undertake the standard walk-around check before boarding the aircraft. With assistance from the ground crew, they strap in and then don their bone dome helmets and flame-resistant gloves. The next task involves conducting a cockpit check with the aid of a specialized checklist. All moving surfaces undergo a final visual inspection and testing as the ground crew remove flagged pins and safeties, which are then prominently displayed to the pilot. Loaded with 12 bombs and a centerline drop tank, the F-4B of Marine Fighter Attack Squadron 115 taxis out for takeoff, accompanied by other Phantoms slated for the mission joining up on the runway. Before receiving clearance for takeoff, the crew verifies that the outer wings are securely locked down, then proceeds to embark on another tactical sortie in support of Marine Corps ground forces. As the scope of US operations in Vietnam expanded steadily during the later 1960s, there was a corresponding increase in the expansion and enhancement of bases utilized by aircraft like the Phantom, which necessitated fully paved runways. Marines are depicted laying a temporary extension to a paved runway in the image. Ground operations necessitated support around the clock and in all weather conditions, highlighting the crucial role played by Marine Aviation Phantom squadrons in facilitating the success of Marine Corps ground forces in Vietnam. Phantom pilots took pride in their ability to deliver a wide array of ordnance with precision, particularly in close proximity to friendly forces' forward positions, a capability that proved pivotal in crisis situations. The ability to rapidly respond allowed constant pressure to be applied on the enemy, whose precise location was communicated via radio relay by ground forces or a forward air controller. Waves of aircraft ensured sustained air pressure on hostile ground forces and enabled the deployment of various types of ordnance tailored to the circumstances of each tactical scenario. The US Air Force emerged as a major operator of the Phantom in Vietnam, commencing with the F-4C land-based variant of the F-4B, followed by the modestly improved F-4D featuring enhanced ground attack capabilities. Despite susceptibility to communist guerrilla attacks, centralized fueling systems like the one at Cam Ranh Bay offered tactical advantages, prompting their utilization in Vietnam. The Phantom's high fuel consumption posed challenges for holding quick reaction units on the runway, but often circumstances demanded it to swiftly deploy maximum aerial firepower against communist forces. However, this practice exposed crews to heat fatigue under the scorching tropical sun while waiting fully manned and armed on standby. Despite these concerns, the paramount consideration remained the speed of reaction, ensuring Phantoms could be scrambled promptly when needed. After the standard preparation and takeoff, sometimes with reduced fuel to allow the maximum possible war load to be uplifted, the Air Force's Phantoms often linked up with a Boeing KC-135 tanker to top up their tanks and thus increase combat radius with a war load of up to 16,000 pounds of external stores. Here, the boomer aboard the tanker aircraft guides the boom into the Phantom's dorsal receptacle for fuel transfer. Renowned as the quintessential attack aircraft in Vietnam, the Phantom offered an impressive combination of payload capacity and range, coupled with robust airframe strength and advanced avionics, ensuring precise targeting with remarkable accuracy. This footage, captured during an attack, vividly demonstrates the Phantom's capability to engage heavily defended targets in North Vietnam as effectively as less fortified targets of opportunity in the war-ridden terrain of South Vietnam. Targets outside of South Vietnam included critical communication networks, power plants, and strategic stockpiles, all heavily guarded by anti-aircraft artillery and missiles. Even in adverse weather conditions, Phantoms demonstrated their ability to penetrate defences and deliver their payloads. The Vietnam War saw the deployment of the entire spectrum of tactical weapons by the USAF, encompassing various types of freefall and retarded high-explosive bombs. Retarded bombs were specifically designed to allow attacking aircraft to drop them accurately at low altitudes to maximize the force of the explosion. In coordinated operations, Phantoms would operate in tight formations at medium altitudes, with all aircraft releasing their bombs upon the leader's command to achieve maximum concentration of ordnance. Napalm emerged as a particularly vital weapon in the US tactical arsenal during the Vietnam War. While the initial F-4C proved effective, it underwent development into the F-4D with enhancements such as the APQ-109A radar replacing the APQ-100 and the ASG-22 sight. However, both models lacked an internal gun, leading to the frequent use of cannon pods in both air-to-air and air-to-surface roles. Pictured here is an SUU-16A pod loaded with 1,200 rounds of 20mm ammunition. The pod incorporates an external ram turbine to power the cannon, restricting the aircraft to speeds below 400 miles per hour during the firing pass. Thus, its use was confined mainly to the air-to-ground role, as demonstrated in these sequences of typical ground attack passes. The SUU-16A and the SUU-23A self-powered versions, designed for high-speed air-to-air engagements, served as solutions, albeit not ideal ones, to the Phantom's lack of an internal gun. Additionally, the Phantom operated with air-to-surface missiles, like the 12,000-yard range Bullpup. As previously mentioned, its primary air-to-air armament consisted of the medium-range Sparrow and short-range Sidewinder missiles. Although air combat was infrequent during the Vietnam War, encounters with MiG fighters did occur, often resulting in successful engagements, such as the one depicted here with a Sparrow missile, or through cannon fire, as captured in classic camera gun footage. The definitive USAF version, the F-4E, introduced an M61 Vulcan 20mm cannon in the lower nose, along with the smaller diameter APQ-120 radar, uprated engines, a slotted tailplane, and maneuvering slats on the outer wing panels. Similar to earlier Phantom variants, provision was made for podded electronic countermeasures like the jammer pod, seen here, carried in the port-forward Sparrow missile recess. The Phantom quickly garnered significant export orders and emerged as the Western world's most vital tactical fighter. The Phantom saw service with 11 overseas operators, including Australia, Greece, West Germany, Turkey, South Korea, Japan, Iran, Egypt, Israel, Spain, and the United Kingdom. Despite not being the third largest purchaser of Phantom aircraft in terms of numbers, the UK pursued a significantly modified variant derived from the US Navy's F-4J. Designated as the F-4K for the Royal Navy and the F-4M for the RAF, this variant featured two Rolls-Royce Spey afterburning turbofans. This necessitated substantial revisions to the fuselage, although the additional drag resulting from these modifications offset the advantages of the more powerful and fuel-efficient power plant. The naval variant, known as the Phantom FG Mark I, boasted the AWG-11 fire control radar and incorporated various British features. Its armament included the Sparrow missile and the 2-inch rocket, the latter housed in multiple pods, mounted under the wings. The FG Mark I remained in service with the Fleet Air Arm until the Royal Navy was forced to phase out its fixed-wing carrier strength in the mid-1970s. Following the allocation of survivors from the Fleet Air Arm's 52 aircraft, the Royal Air Force operated the Phantom FRG Mark II, equipped with the AWG-12 fire control radar and a British navigation attack system. Peacetime ground attack training typically involved rockets, cannon pods, and practice bombs, as depicted in the accompanying sequence.
Roger, about 5 degrees coming on to the attack heading now. Contact the target, master arms going on, and the camera's going on. Going right a bit. Firing now, and pulling. Downwind now for a priority landing.
Roger, Red Leader, join.
Gears down. On speed.
The 150 British Phantoms primarily serve in air defence roles over the UK, with a secondary responsibility for fighter ground attack missions. Number 41 Squadron exemplifies one of the 7 British Phantom squadrons, with 2 squadrons flying ex-naval FG Mach 1 variants and a 3rd squadron operating ex-US Navy F-4Js. The latter was necessitated by the RAF's increased commitment in the South Atlantic following the Falklands War of 1982. Modern developments have highlighted alternative roles for the Phantom, such as reconnaissance and defence suppression. One of the most significant developments has been the creation of the F-4ES, high-altitude photo reconnaissance variant of the F-4E, exclusively utilised by Israel. This variant features a completely modified nose section to accommodate special HIA C1 oblique photo equipment, enabling the high-altitude aircraft to surveil deep into enemy territory while remaining in the relative safety of friendly airspace. Israel is also undertaking upgrades to its fighter models. Additionally, countries like Japan, South Korea and West Germany envision a future for their fighters, following extensive upgrades by their respective aircraft industries. Throughout its service history, the Phantom has demonstrated remarkable adaptability across a wide range of roles, utilizing various weapon types on its 5 hardpoints. Some of the most important are illustrated in the next few sequences. Unguided rockets have played a particularly significant role in area ground attacks. Among the most commonly utilized types are the 2.75-inch rockets, with the 5-inch variants being less frequently employed. These rockets are fired from launchers of various sizes and are effective against soft battlefield targets such as troop concentrations, unarmored vehicles, and artillery positions. In the air-to-air role, the short-range infrared-guided Sidewinder has proven more successful than the medium-range Sparrow. The Sidewinder locks onto the heat emitted by the target, providing reliable targeting compared to the Sparrow, which homes in on radar reflections bouncing off the target. The Phantom can carry up to 4 Sparrow missiles under the fuselage and 2 or 4 Sidewinders on underwing hardpoints, offering maximum flexibility in air-to-air engagements. In the depicted sequence, a Convair F-102 Delta Dagger pilotless drone serves as the target. A late-model Sidewinder successfully hits the drone's tailpipe, demonstrating the effectiveness of the weapon. Following the successful hit, the drone experiences successive breakup as it tumbles out of control. Both saturation and precision bombing have been conducted against point and area targets, utilizing a wide range of US bomb types, including highly effective high-blast demolition types. Cannon pods have also proven highly successful in the air-to-ground role, with 20mm pods being more common, although 30mm pods can also be carried. Multiple pods have demonstrated devastating effectiveness in air-to-surface operations. As the most important type in US Navy and US Air Force service during the 1960s and early 1970s, the Phantom was utilized by aerobatic display teams of each service. The Navy's team, the Blue Angels, operated the F-4J until the rising fuel prices necessitated a change to the McDonnell Douglas A-4F Skyhawk in 1974. Similarly, the Air Force's team, the Thunderbirds, flew the F-4E until transitioning to a smaller and more economical type. In this instance, the Northrop T-38A Talon. The Phantom stands as the Western world's most widely built and extensively utilised combat aircraft since World War II, making its production milestones notable achievements in aviation history. The 1000th Phantom, an F-4B for the US Navy, was delivered on July 7, 1965. 2 years later, the 2000th Phantom, an F-4D for the Air Force, followed on February 21, 1967. Just 17 months later, on August 28, 1968, the 3000th Phantom, an F-4J, was produced for the US Navy. An F-4E for the Air Force became the 4000th Phantom on February 1, 1971. Finally, on May 24, 1978, the 5000th Phantom, an F-4E, was delivered to the Turkish Air Force. Although the Phantom is no longer in production, it remains an effective warplane. A classic fighter isn't just one that performs well under ideal conditions, it's one that accomplishes missions beyond its original design. The success of the Phantom was a result of the courage and skill of its crews, supported by an aircraft that was capable and versatile enough to adapt to various missions. The F-4 Phantom was neither pretty nor elegant, but it did its job when so many other aircraft in history could not. That's what counts.
This is the McDonnell Phantom II, a powerful and steadily growing force for the defense of the free world. This is a pilot's airplane, and the Phantom's flight crews have adapted quickly to the aircraft's power and ease of handling to demonstrate time and again that this is the most versatile air weapon in the world. They have demonstrated it not only in official military tests, but by a series of official world records, which stand as a reassurance to America and her friends, and a warning to her enemies. The Phantom has 2 engines for power and reliability, and 2 crewmen for efficient weapon delivery. As an interceptor, it carries both heat-seeking sidewinders and radar-guided Sparrow missiles to destroy attacking aircraft. For long-range attack and troop support, the Phantom can deliver a wide variety of conventional or nuclear weapons. As a Navy fighter, the Phantom operates from aircraft carriers. It can fly efficiently from World War II carriers with their limited deck space, as well as from the latest supercarriers, taking full advantage of their multiple launch facilities. Its stable landing approach brings it safely aboard. This same slow flight capability also enables it to operate from relatively small land bases. Many other capabilities have been proved by strenuous test programs: range, speed, endurance, and reliability. These qualities were emphatically demonstrated as the Navy showed the Phantom's performance to the world by an all-out assault on existing world records. A look at these records will dramatically illustrate the fighting power of the distinguished Phantom II. An intruding bomber, for instance, may be flying at an extremely high altitude. To down the enemy before he can strike his target, an interceptor must be able to take off and climb swiftly to his altitude. Early in the development phase, Project Top Flight proved the zoom climbability of the Phantom. Carrying recording instruments sealed by officials of the National Aeronautics Association, Commander Larry Flint took off from Edwards Air Force Base in California in an attempt to better the existing altitude record. After a level flight speed buildup, peak altitude would be reached in a zoom. His momentum carried him upward into the stratosphere to an altitude of 98,557 feet. As the aircraft dived toward Earth, instruments in the aircraft, as well as those on the ground, indicated that the Phantom had set a new world altitude record. This was confirmed by the Fédération Aéronautique Internationale and its American affiliate, the National Aeronautic Association. An effective interceptor must also be able to hold a high altitude for a sustained period, to reach out toward the enemy before he reaches his target. Another world record demonstrated that the Phantom can do this too. Top Flight was a zoom above the normal operating altitude. This time, Commander G.W. Ellis flew through a straight 25-kilometer course at 66,443 feet to establish a new world record for sustained altitude. He maintained an average speed well over Mach 2 through the course. This record, like all the Phantom's other records, was made official by the FAI. Split seconds assume immeasurable importance as an interceptor moves to launch its missiles against incoming attackers. Here, the Phantom's speed pays off. Speed that has been proved officially 3 times, both in straightaway flight and in turns. One of these races against time was Project Skyburner. Its purpose was to establish the all-out straight and level speed of the aircraft, and thus demonstrate its ability to attack and re-attack evasive targets. Radars and optical trackers followed as Lieutenant Colonel Robert B. Robinson flashed through a straight 15-kilometer course over the dry lake near Edwards Air Force Base. As required by FAI rules, he turned and repeated the run in the opposite direction, reaching a peak speed of over 1,650 miles per hour. His average speed of over 1,606 miles per hour, Mach 2.57, made the Phantom the fastest jet-powered aircraft in the world. But straightaway speed is not enough. To utilize its multiple missile load against enemy bombers, the fighter must be able to turn and maneuver at high speed and altitude. The Phantom proved this capability in 2 record-breaking flights around both long and short courses. The first course was a 500-kilometer triangle. Precise maneuvering was required to enter the starting gate at high speed and on course, and to negotiate the sharp turn at the far end. Colonel Thomas Miller flashed around this course at an average speed of over 1,216 miles an hour. This was 400 miles an hour faster than the previous record. Another record was slated to fall as Commander John F. Davis took off for an even more exacting flight over a 12-sided course, only 100 kilometers around. Maneuvering precision was critical. The pilot was guided only by a radar plot, and if one wingtip should slide inside the markers, he would be disqualified. On the other hand, if he should fly too wide, his flight path would be too long, and his calculated speed would therefore be lower. But careful planning and practice paid off. On the record flight, Commander Davis held the Phantom in a steady 3G turn at 45,000 feet, averaging over 1,390 miles an hour. Once again, the data showed that the Phantom had set a new record. McDonnell engineers designed the Phantom to be an attack bomber as well as a fighter, and its bombing capabilities too have been well illustrated by official world records. Let's look at Sageburner. One very effective bombing technique is to approach the target at high speed and low altitude, thus hiding the aircraft from enemy radar and observation, and gaining the advantage of surprise. To demonstrate the Phantom's suitability for this type of attack, the Navy undertook to fly a straight 3-kilometer course at top speed, less than 300 feet above the ground. Lieutenant Hunt Hardesty as pilot and Lieutenant Earl D. Esch as radar observer made repeated supersonic passes over this course at an average speed of 902 miles per hour, Mach 1.2, averaging only 125 feet over the terrain, and sometimes flying as low as 50 feet. The density of the air at this extremely low altitude, coupled with supersonic speed, made severe demands on the pilot's skill, as well as the structural strength and controllability of the aircraft. Announcing this world record, Admiral George W. Anderson, Chief of Naval Operations, said, "The 3-kilometer record is one more bit of proof that the Phantom II is one of the best fighter aircraft in the world." The world is the Phantom's sphere of influence. In fact, operating from carriers and existing friendly shore bases, the Phantom can bring its fighting ability to bear on 96% of the world's surface, and do it quickly and efficiently. Project Lana proved the Phantom's long-range speed. Lana commemorated the 50th anniversary of naval aviation by showing the Navy's ability to deploy rapidly to far-off trouble spots. A group of Phantoms equipped for combat crossed the country non-stop from coast to coast faster than any aircraft had ever done before. The start was from Ontario, California, and the finish line was New York's Floyd Bennett Field. The fastest plane of the group would also win the famous Bendix Trophy. There were 3 in-flight refueling points over New Mexico, Missouri, and Ohio. When all was ready, the starting command came from NORAD headquarters. The Phantoms roared off the runway at Ontario at timed intervals. The Air Defense Command and the Federal Aviation Agency had organized an electronic network for flight surveillance and communications. At the first refueling rendezvous, the Phantoms dropped to the tanker's altitude and slowed to match the tanker's subsonic speed. Then, fuel replenished, they were off again at their own high altitude and supersonic pace. After the 3 lead Phantoms completed all refuelings, they began their letdown. All 3 broke the record. The best time was set by Lieutenants R.F. Gordon and B.R. Young in the 3rd Phantom. They had spanned the country in 170 minutes at an average speed of over 869 miles per hour. These official records, impressive as they are not only significant for themselves alone. They serve to show the people of the world the true power of one of America's newest and best defenders of freedom, the versatile Phantom II.
The F-4 Phantom II is a versatile tactical fighter. It can be used as a fighter bomber, interceptor, or as an air superiority fighter. To gain and maintain air superiority is, in part, the mission of the Tactical Air Command. F-4 pilots assigned the specific mission of seeking out and destroying enemy aircraft in the air and on the ground must understand and be proficient in aerial combat maneuvering. Air-to-air combat is a swift and deadly game. Victory or defeat may be decided in only a few seconds. Mission success, and usually your life, depend upon a thorough knowledge of your weapons and weapon system, as well as those of the enemy. Pilots assigned combat duty will be exposed constantly to situations where only the most skillful maneuvering, teamwork, and timely application of basic air combat tactics will enable them to emerge victorious. Flying the F-4 in air combat tactics training, as well as in combat itself, demands an ability to maneuver the aircraft at maximum performance. To do this, the pilot must have an understanding of adverse yaw and dihedral effect. Adverse yaw is defined as yaw that is opposite to the desired direction of turn. At subsonic speeds and high angles of attack, rudder must be used in the F-4 to offset this yaw. This yawing moment is caused in part by the aileron on the top wing, left wing in a right turn, being deflected down and causing more drag than the spoilers on the low wing, because these spoilers are operating in a lower pressure area. One example of dihedral effect, and perhaps the easiest to understand, is the characteristic of any swept-wing aircraft to obtain more lift from a wing that is straightened out into the relative wind. The opposite wing is, in effect, swept further back. For this reason, the F-4 can be rolled with rudder. When performing a hard turn, as angle of attack begins to increase, the pilot may be tempted to tighten the turn by using more aileron. This adds to the undesirable condition, and if these improper controls are held, a snap roll-away from the desired turn may result. This could be disastrous in combat. To prevent a snap roll or post-stall gyration, the pilot must, when subsonic at high angles of attack, use rudder to control roll rate and bank, hold the ailerons neutral, and control turn rate with backstick pressure. Caution: develop a feel for the rudders. Do not arbitrarily jam full rudder in the direction of turn, or dihedral effect will cause a roll in the direction of applied rudder. With proper training, the F-4 pilot will have no trouble in developing a feel for his aircraft and flying it to maximum performance. Remember, you are flying the airplane, not riding it. The basic fighting unit is the two-shift element. It is much more maneuverable than a flight of four. The leader must, however, spend a great deal of his time clearing the wingman rather than looking for potential targets. When the element is used as a part of a flight of four, the wingman flies a position 1,000 to 3,000 feet out from the lead, depending on altitude, and from line abreast to 20 degrees back. Flying this position, the wingman can cover the leader's 9 o'clock to 3 o'clock area through the rear hemisphere, his primary area of responsibility. During turns, the wingman maneuvers in the horizontal and vertical planes. By playing the outside as well as the inside of the turn, the wingman can easily maintain position, conserve energy, and provide visual coverage in the rear hemisphere. When on patrol, the wingman stays well forward in easy view of the leader. He maintains coverage in the rear hemisphere while the leader searches for the enemy. The distance between aircraft may be increased at higher altitudes due to increased enemy missile performance. This increased separation extends visual coverage in the rear hemisphere, moving the blind spot farther out. Upon initial contact with the enemy, the wingman must move to the maximum performance maneuvering envelope. The size and shape of this envelope varies, but generally it is a cone 60 degrees to 90 degrees from the leader and 1,000 to 1,500 feet back. These distances and angles may vary as long as the wingman is able to provide mutual support and visual coverage during violent maneuvers. The primary duty of the wingman while flying in the maximum performance maneuvering envelope is to provide coverage in the rear. To maintain position and to perform his duties, the wingman will need a degree of skill and proficiency which is gained only through practice. When flying in the maximum performance maneuvering envelope, the wingman provides the leader with a spare weapon system should his own malfunction.
My gun's jammed. Take him, too.
Should this occur, the wingman moves forward, assumes the lead, and maintains whatever advantage the leader may have had. If at any time the wingman cannot perform his duties, he should notify his leader immediately. The offensive potential of the two-ship flight is greatly enhanced when it is used as part of the basic combat patrol formation. This is a four-ship flight comprised of two mutually supporting elements. In this formation, the leader plans the attack and engages the enemy. The number 3 man, or element leader, supports the flight leader and assists in the attack. The number 2 and 4 men support their respective leaders and cover the vulnerable 6 o'clock areas. Since the element leader functions as alternate flight leader as well as leader of his own element, he is selected for his demonstrated leadership, ability, and aggressiveness. The supporting element is flown 3 to 9,000 feet out from the leader, and 0 to 5,000 feet up. These distances will depend upon altitude, configuration, and mission requirements. This is because of decreased enemy missile performance in denser air and the difficulty in seeing camouflaged aircraft at low altitudes. Visual contact must be maintained. While on patrol, the element leader may maneuver his element from a position of line abreast to a maximum of 10 degrees back. During turns, the element maintains this position by energy-altitude trade-offs. Generally, this type of maneuvering will require one crossover for every 90 degrees of turn. The leader will usually turn 90 degrees or in 90-degree increments. If not, he'll inform the element leader so that he may plan his crossover so as to be in correct formation position when the leader rolls out. There are 2 points that deserve special emphasis. First, wherever possible, the supporting element is flown down sun. Second, great care must be taken when crossing over in the fluid 4 formation to prevent mid-air collision during the brief periods of reduced visual contact. correct employment of visual search techniques by each member of the flight will provide good detection rates at ranges of 3 miles or more in the rear hemisphere. The flight leader searches the forward hemisphere from 15 degrees above the horizon downward. The lead also makes casual checks of his element and its rear area. The element leader, in addition to maintaining his position, searches the forward hemisphere from 10 degrees below the horizon upward. The right wingman searches the area from the flight leader's 9 o'clock position to the rear as far as he can see. The left wingman searches the area from the support leader's 3 o'clock position to his rear as far as he can see. The use of small check turns will improve the 6 o'clock coverage by displacing the blind spot from side to side. Laxity in performing scan responsibilities cannot be tolerated. This is equally true in regard to radar search. Radar coverage in a flight of 4 is improved when each flight member searches a definite area with a minimum overlap. The lead aircraft selects 1-bar scan, radar mode, 50-mile scope, and adjusts the antenna elevation so that approximately half-inch ground return appears at the top of the scope. This radar search pattern supplements the leader's visual search area. The rear seat pilot maintains constant radar surveillance of his area. The number 3 man or supporting element lead selects 3-bar scan, radar mode, 50-mile scope, and adjusts the antenna to obtain half-inch of ground return on the lowest sweep. He then selects a 1-bar scan, thus automatically raising the antenna to the desired elevation. This radar search pattern supplements the element lead's visual search area. The number 3 rear seat pilot, like the lead rear seat pilot, concentrates exclusively on radar scan. The number 2 man selects 1-bar scan, radar mode, 25-mile scope, and adjusts the antenna so that half-inch of ground return appears at the top of the scope and maintains that search position. While the number 2 aircraft commander is scanning his visual search area, the rear seat pilot divides his time evenly between the radar and a visual scan of the same area scanned by his aircraft commander. The number 4 man selects 1-bar scan, radar mode, 50-mile scope, and adjusts the elevation strobe to 8 degrees up. He then selects 3-bar scan for search. The rear seat pilot in the number 4 aircraft, like the number 2 rear seat pilot, divides his time evenly between visual scan and radar scan. The number 4 aircraft radar scan area combined with the number 2 radar scan area provides a thorough long-range detection capability in the forward hemisphere when combined with the visual and radar scan of the lead and supporting element. It can be said that the air battle consists of 3 phases: acquisition, maneuvering, and terminal. Acquisition. You must find the enemy to engage him. Maneuvering. You must outmaneuver the enemy to destroy him. Terminal. You must know your weapons and weapon system to hit him. The F-4 has an excellent long-range air intercept radar. If properly used, this radar can be a decisive factor in the air battle. With this long-range detection capability, it is probable that contact will occur in the forward quadrant prior to visual contact. The problem of visual identification of bogies must receive special attention. Proper interpretation of radar returns can provide valuable information at sufficient range and time to allow the attackers to maneuver to gain tactical advantage prior to visual contact. When equipped with all aspect missiles and in a front hemisphere attack, separate the elements to achieve a first-pass ID and missile launch. A good rule of thumb to determine minimum contact range necessary to gain the separation for attack is approximately 3 times optimum missile range. For example, if optimum missile range is 5 miles, then minimum contact range is 15 miles. If contact is made at sufficient range, the ID element should make a descending acceleration using afterburner to 1.2 Mach. The launch element executes a barrel roll or S maneuver to obtain desired separation in minimum time. While gaining separation, the ID element wingman should make a thorough radar search of the area for other aircraft that could be a threat. The ID element lead maintains radar contact and maneuvers for a collision course. After allowing the ID element to gain the desired separation, the launch element also accelerates to 1.2 Mach and maintains a target lock-on while keeping visual contact with the ID element. As soon as visual ID can be made, the ID element lead relays to the launch element lead the identification of the target aircraft, and, if it is enemy, clears him to fire.
MiGs, 21s. No missiles on board. Clear to fire, clear to fire.
If the ID element is undetected passing below the enemy, or if the enemy fails to maneuver, the ID element should employ basic fighter maneuvers to re-attack or support the launch element. If, however, the ID element is detected and the enemy maneuvers against it, they may employ counter-maneuvers against the enemy or continue a straight-ahead run-out, while the friendly launch element sandwiches the enemy. When the ID is made and clearance to fire received, the launch element executes either a front or a rear hemisphere attack, depending on the enemy's actions. Both elements then engage the enemy, supporting each other until the enemy is destroyed. When attacking from a beam, the separation required is less, and it is easier to attain. On the initial visual identification pass, the ID element may fire if identification can be made soon enough. If not, he turns 180 degrees from the target's heading and maneuvers for a follow-up attack. The turn will put him out of the target area and allow the launch element a shot as they follow and maneuver for a missile or a gun attack. The two elements then fight as a team until the enemy is destroyed. In a stern attack, you must consider the range to target, fuel required to close, and your heading. A stern chase is useless if bingo will occur before identification or firing range. A stern approach, however, is the best position for surprise in a missile or gun attack. The elements in a stern attack maneuver so as to keep pressure on the enemy at all times and support each other until the enemy is destroyed. When operating as a lone element and attacking a flight of 4, make either a beam attack or a stern attack, since identification and re-attack are the most difficult from head-on. Be very careful to maintain element integrity when attacking as a lone element, since look back from the F-4 is poor. After radar acquisition and initial attack, competence in basic fighter maneuvers is essential in destroying the enemy with either a missile or gun. The high-speed yo-yo is a good maneuver to maintain the advantage when on the attack. Its purpose is to maintain nose-tail separation. As you recognize an overshoot coming up, keep your G's on while reducing some of your bank. Slide high and inside the defender's turn. This will reduce your forward velocity while maintaining nose-tail separation. Watch your opponent and slide back down on the attack. Don't get the nose too low, or you may be forced out the bottom. The low-speed yo-yo is another good attack maneuver in the F-4. Lower the nose and establish your cutoff while nose low. Light the afterburner and accelerate to Mach 1.1 or more. Terminate afterburner and begin pull-up. When the nose is above the horizon, relight afterburner and slide up toward the defender's 6 o'clock. As you slide into your opponent's lethal cone, be prepared to perform a follow-up high-speed yo-yo. The barrel roll attack is an excellent offensive maneuver for a missile or gun attack. When the defender is turning into you while you are still at long range, 8,000 feet or more, and generating angle off, 40 degrees or more, begin the maneuver from low and inside the defender's turn. Play the rate of roll for the desired effect, depending on the range and rate of the defender's turn. If the defender is turning right, you roll to the left, and vice versa. Backstick and rudder is used throughout the entire maneuver to hold the nose in the desired position. Upon completion of the roll, you will find your angle off diminished and the range reduced. If G-load permits, fire a missile when in range. Press the attack and, if need be, execute another barrel roll attack or perform a high-speed yo-yo. While the fighter pilot and his aircraft comprise an offensive weapon, the possibility is strong that the first contact with the enemy will be in the rear hemisphere. This is due in part to the enemy's GCI capability. Thus, it is imperative that you have a thorough knowledge of both offensive and defensive maneuvers. The basic defensive maneuver is the defensive turn. This is a hard turn performed to prevent an opponent from achieving a launch or firing position. With this maneuver, the defender can diminish the lethal envelope and improve his position by rotating his cone of vulnerability away from the attacker. If the attack is discovered closer in, a break may be necessary. This is a maximum performance turn into the attack to destroy the enemy's tracking solution and force him to overshoot. The effect is gained in the first 45 to 60 degrees of turn. If the attacker does not yo-yo and overshoots, reverse, and if you're lined up, take a quick shot at him. If you are not lined up, get him out of phase and dive for separation. If an attacker has been forced to overshoot, another maneuver is the scissors. As the MiG overshoots, make a nose-high reversal and continue with a series of turn reversals. This will rotate your lethal cone away from the attacker and force him again to cross your flight path and eventually to your 12 o'clock position. The scissors is an effort to gain an offensive position. The advantage, however, lies with the aircraft having the shorter turn radius and the lower airspeed. For this reason, the Scissors is not considered a good maneuver against the lighter, more maneuverable MiG series aircraft. After the first couple of reversals, if you cannot get a shot, watch the MiG. Get him out of phase with you, and when he cannot see you, roll rapidly. Engage the afterburner, pull the nose down to vertical, and accelerate out. Bear in mind, you need altitude for this. Should the MiG follow close in, you may set the hook. As he commits himself nose low, reduce power, extend speed brakes, and pull up at maximum performance. This should throw the MiG out the bottom. Roll off and drop in on him. If the MiG does not follow close in, do not set the hook. Accelerate out to at least Mach 1.1, descend to low altitude, and gain separation. A moderate 2G roll while descending should be enough to spoil the MiG's tracking solution on the way down. When on the deck, make random reversals to keep him from getting a tracking solution, while you use the F-4's advantage of speed at low altitude to outdistance the enemy. When out of gun range, stay low if you're still within missile range. When you are definitely clear of the MiG, then pull up and re-engage head-on. When a flight of 4 F-4s is attacked by 2 MiGs, the element under attack should separate either by a straight-ahead diving acceleration or by a turnaway from the free element. The free element then quickly sandwiches the attackers. Again, be doubly watchful for additional MiGs in the area. If both friendly elements are under attack, it may be necessary to fight as lone elements until one element destroys his opponent and is thus free to assist the other element. When defending as a lone element, the defensive split is a valuable maneuver to use instead of the last-ditch maneuver. With the MiGs approaching gun range, for example 4,000 feet out, and remember, that is 4,000 feet out from the wingman, and you are unable to force him out of your lethal cone, call for a split. The low man continues his hard turn into the attack, while the high man slides high, gaining separation on the low man. The attackers are then forced to make a choice. Take the low man, take the high man, split, fake at the low man, and then take the high man, or perform the fluid separation. An analysis of past engagements reveals that the MiGs are unlikely to fake or perform a fluid separation. The defenders must be on the alert. If the attackers split, each defender then defends himself and fights alone until he's destroyed his opponent before he can assist the other friendly aircraft. If the attackers take the low man, he continues the hard turn and goes into a diving spiral to gain separation, while the high man zooms up, then drops down to sandwich the attackers once they're line abreast. Should the attackers take the high man, he performs a moderate G roll-under, ending in a turn away from the low man. The low man then pulls up and sandwiches the attacker as quickly as possible. It becomes readily apparent that teamwork and radio discipline are mandatory for the defensive split. Proficiency in Fluid 4 and air combat tactics comes exclusively from training and practice. This proficiency is the only key to success. Air combat is a deadly game played for the highest stakes in the world. Your life and the life of your buddy. With so much to lose, there is no room for error. The knowledge gained in an aggressive air combat tactics program, combined with the skills developed in air-to-air gunnery training, will provide the tactical fighter pilot the tools necessary to engage and destroy the enemy in the fight for the sky. Good luck and good hunting.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.